Hello everybody. So far we've talked about solving quadratic equations by factoring, and that only works with quadratic equations or expressions that can be factored. So what happens when we have something that can't be factored? Well, we have to use this other procedure called completing the square. Um, when we go to equations like this, these are really easy to solve. When we have something squared is equal to just a number, then we just take the square root of both sides, and actually it's the absolute value of x is equal to 3, so x is equal to 3 or negative 3. So it's really nice if we can get something that's a perfect square like this equal to a number. And it even works when we have just like a whole thing, like x plus 1 quantity squared equal to 9. Then I can square root both sides and say x plus 1, the absolute value of it, equals 3. I like square rooting both sides. And so x plus 1 equals 3, or x plus 1 equals negative 3. So then I just subtract 1 from both sides, and I could get x equals 2, or subtract 1 from both sides of this one, I get x equals negative 4. So those are my two solutions to that equation. So if I can make it like this, then I can use that idea. So what if I had this equation right here, x squared plus 2x plus 1, and let's say it equaled 9. So can I transform that into a perfect square? Well, let's see, I have my x squared and my 2x's and my 1, so can I rearrange these in a way that it would look like a square? Well, yes I can. I can split this in half and put one of the x's here and one down here, and then I fill in this spot right here with my 1, right? So now this is a square that is x plus 1 on this side and x plus 1 on this side. So the equivalent expression would be x plus 1 quantity squared equals 9, which I just solved up here. So x would be 2 or negative 4. And this is going to be a procedure that all you have to do is think about what is the square that I want. So what if I had this x squared plus 4x, I don't know, minus 3 equals 0. So is it possible to break this up? So I would just split this in half, right, to make this into a square. And now I need to fill in this spot with a number of 1's, right? So this is x plus 2 times x plus 2, so 2 times 2 would equal 4. So I need to fill in this spot with a 4. But right now the equation says 3, so I want to make sure that that's a 4, so what do? I just change it, right? If I don't like something in the world, I just change it. So I'm going to move this 3 to the other side. Normally we'd set it equal to 0, but now we don't really care about what's on this side because we're going to take the square root. So I'm just going to move that 3 over and have a blank there. So I have x squared plus 4x plus blank, that's 0, right, equals 3. So now what am I going to add to make that a perfect square? I need to add 4, right? So I add 4, and whenever I add something to one side, I also have to add it to the other. So I have to add 4 to this side. Okay, so this is that perfect square, x plus 2 quantity squared is equal to 7. Now I can just take the square root of both sides. So this is x plus 2, the absolute value of it, equals 7, or x plus 2 equals 7, or x plus 2 equals negative 7, or sorry, square root of 7, or the negative square root of 7. So now I just need to subtract 2 from both sides to find out what x equals. So I'm just going to put the 2 in the front because I like to put my square root at the end. So minus 2 from both sides, and then it's plus a square root of 7. So this is kind of looks a little bit different than you're used to, but this is also a real number. We could put it into our calculator and get a decimal approximation, but it's not a whole number, is it? It's an irrational number, but that's okay. We can still use it. So I'm going to subtract 2 from both sides here and get x equals -2 minus the square root of 7. So that square root of 7, it's something between 2 and 3, right? Because the square root of 9 is 3, and the square root of 4 is 2. So it's something like, I don't know, 2.5. So it's -2 plus 2.5 and -2 minus 2.5, something like that. If you want to put it in your calculator, you could find out for sure. So these are the solutions to this original quadratic equation, and I can even check my answer. I'm just going to plug this whole thing in for x, and I'll just do one of them, not both. So is this true? If I plug in this value, -2 plus the square root of 7, quantity squared right here, is it equal to 0? So I have to square this. So it's kind of like doing the same thing times itself, right? So it's kind of like multiplying a two binomials together. So I'm going to do it like this. And then 4 times that would be, let's see, 4 times -2 is -8. And then 4 times that would be 4 times the square root of 7. Alright, so -2 times -2 is +4. -2 times the square root of 7 is -2 square root of 7. And then square root of 7 times -2 is -2 times square root of 7. And square root of 7 times the square root of 7 is just 7, right? Square root of 7 times the square root of 7 is square root of 49, which is just 7. -8 plus 4 square root of 7 minus 3 equals 0. So is this true? So I have -2 square roots of 7 here and -2 square roots of 7 here. So I have -4 square roots of 7. And then I have +4 square roots of 7 over here. So these -4 are going to cancel out with this +4. So those just go away, right? And then 4 plus 7 is 11. -8 minus 3, that's -11, right? So that's going to be 0, right? 4 plus 7 is 11. -8 minus 3, that's -11. So it's just equal to 0. So it's kind of surprising how it just all cancels out like that, but these are the two solutions to that quadratic equation. And you could never, you could factor it into this, but it would be really hard to guess, right? That you could factor it this way. Yeah, I think it's actually like this. Yeah, it factors into this, but you could never come up with that. You have to kind of go through this process of completing the square. So let me just do a couple more examples of completing the square so we get a good sense of it. So what I'm going to do is I'm going to move this to the other side so that I have this blank spot. So I'm going to add 2 to both sides. And now I want to put the number in there that would complete this square. So I have to think about it. I'm going to have x squared plus 6x's. Right. So I have 6x's here. And then I'm going to split it in half and make it into this nice square that would be x plus 3 and x plus 3. So I need 9 units to go in that spot right there, 3 times 3. So what I want to do is have a plus 9 here so that this is a perfect square. So if I add 9 to this side, I have to add 9 to that side. So I get this 11 over here. And this is equivalent to what I just squared, right? I squared the 3. So this is x plus 3 quantity squared. And then I square root both sides. X plus 3 equals the square root of 11 or the negative square root of 11. And then I subtract 3 from both sides, or all my solutions. So I get x is -3 plus the square root of 11 or -3 minus the square root of 11. So those are my two solutions. One more. So this is x squared equals x plus 1. So the square of some number is equal to that same number plus 1. Seems like they're, if you could think about it, it seems like a very simple equation, but it can't be factored actually. So let's move it over here. Minus x and So I'm going to subtract x from both sides and subtract 1 so I get it in my nice standard form. But actually I'm going to think about completing the square, so I might want to leave the 1 over there, so I'll just put the 1 back over here. Let me just show you that this can't be factored, right? If I take the first and last term, put it on top, it'd be -1. Middle term on the bottom is -1. So what do I multiply to get -1? But when I add, it's -1. So the factors of 1 are only 1, right? Whole numbers 1. So one of them has to be negative, and there are no other factors of 1, right? So when I add them together, I get 0. So it doesn't work, right? So it's not factorable, at least in whole numbers, integers. But I can solve it using this completing the square method, which I'll show you. So I add 1 to both sides to leave the blank there. So what am I going to add to make that a square? Well, I'm just going to draw my general rectangle here. So I have x squared here, and remember I split the coefficient of this in half and put those two things there. So what is half of negative x? Well, it's just -1/2 x, right? -1/2 x goes here and here. And then what goes in here is the square of these two numbers, right? Because I have x and times x is x squared, and then x times -1/2 would be that term, and then x times -1/2 would be that term. So you have your square, x minus 1/2, x minus 1/2, and then -1/2 times -1/2 is +1/4. So that's the number that I want there, is +1/4. So to add to that side 1/4, I have to also add to this side 1/4, and my square is completed. So this is equivalent to x minus 1/2 quantity squared, and this is equal to, let's see, 1 is equivalent to 4/4, right? So 4/4 plus 1/4 is 5/4. And now I can take the square root of both sides. So I get x minus 1/2 is equal to the square root of 5/4 or the negative square root of 5/4. And then I add my 1/2 to both sides to get my x by itself. So I'm going to add 1/2 to everything. So I get x is equal to 1/2 plus the square root of 5/4. Well, I don't like square roots in the denominator in the bottom. So the square root of 4 is 2. So I'm just going to simplify that to square root of 5 over 2. Or it's the minus, right? So 1/2 minus the square root of 5 over 2. So those are my two solutions. And you could even plug these back in and check that this number, 1/2 plus the square root of 5 over 2, is, when I square that number and I take that number and I add 1 to it, it is the same, right? So let's just do that. 1/2 plus the square root of 5 over 2. I'm going to square that, and I'm going to add 1 to it. So 1 is the same as 2/2. So I have 3/2 plus the square root of 5 over 2. Okay, is that side of the equation? And then I'm going to square this. So it's actually like multiplying two binomials together. So 1/2 times 1/2 is 1/4. And then 1/2 times that would be square root of 5 over 4. And then multiply these two. So square root of 5 over 2, that'd be again square root of 5 over 4. And this would be square root of 5 times square root of 5 would be just 5/4. Okay, so I could combine these two to make 6/4. 6/4 is equivalent to 3/2, isn't it? And I'd have square root of 5 over 4 plus square root of 5 over 4 would be 2 square roots of 5 over 4, and then I could simplify that to make it that. So I'd have this side of the equation is equivalent to this side of the equation. These two combine to make 3 halves, and these two combine to make square root of 5 over 2. So that checks out.